Hey there, we're going to work through a couple more examples solving some of these trickier types of radical equations where we have variables and terms that are also outside of the square root in addition to what we've got inside here. So the first thing that we want to do when we're solving any radical equation is get the square root part of the equation by itself so that we can square both sides to get rid of that radical. So what we can do in this case is add 6 to both sides, and since these are not like terms, x and 6, we're going to have to leave those as two separate terms on the other side of our equation. So now we have the square root of 7x plus 50 equals x plus 6. To get rid of this square root, we can square both sides of the equation. And when we square this x plus 6, we've got to be careful that x plus 6 all squared is not the same thing as if we just write x squared plus 6 squared. If we're squaring more than one term, we need to multiply this out as a polynomial and multiply x plus 6 times itself. And to multiply this polynomial out, we have to distribute x times x gives us x squared. 6 times x is plus 6x. X times 6 is plus 6x. And 6 times 6 gives us plus 36. We can combine together these like terms, 6x plus 6x, to get 12x. So now the equation that we're dealing with actually no longer has a radical in it, because when we square the side of the equation that has the radical, the square root and the square cancel out, and we just have 7x plus 50. And on the other side of our equation, we have this set of terms that we got from squaring x plus 6, which means we multiplied it times itself and got x squared plus 12x plus 36. And now the rest of this is going to be a polynomial equation that we can solve. And we can solve this polynomial equation using factoring or any of the other techniques that we've learned to solve quadratic equations. So let's continue that on another screen with more space. So now we're trying to solve this polynomial equation I've got written here in black. And I've also got the original equation that we had started with, just so that we keep in mind that what we're really solving here was originally a radical equation, which means that at the end we do need to check our answers by plugging them back in. So to solve this polynomial, it's going to be easiest if we put it in standard form with all of the terms on one side of the equation and the other side equal to 0. And the easiest way to solve this is going to be if the leading coefficient on the x squared term is just positive 1. So since we already have positive x squared here, let's move these other terms over to that side of the equation, which we can do by subtracting from both sides, so that what we have on the left side will cancel out. If we subtract 7x from the right side of our equation, we have some like terms that we can combine. We're going to combine the 12x and negative 7x to get positive 5x. And we can also combine these constant terms, plus 36 and minus 50 gives us minus 14. So the quadratic equation that we're going to solve now is x squared minus 5x, x squared plus 5x minus 14 is equal to 0. And we can solve this by factoring. We're looking for solutions to this number puzzle. What two numbers can multiply to equal -14 and add to equal +5? We can use the numbers -2 and +7 to do that. So we can rewrite this equation in its factors. 0 equals x minus 2 times x plus 7, which gives us two possible solutions. If we set each of these factors equal to 0 and solve for x could equal +2 or x could equal -7. But we weren't just solving a polynomial equation. The original equation that we were solving had a square root in it. And since we squared both sides as one of the steps in simplifying that equation, we need to check these answers by plugging them back into that original equation. So let's check and see if x equals 2 is a valid solution. We're going to take the original equation that we had, but anywhere that there was an x, now we're going to replace that with +2. And we want to simplify the left side of this equation and make sure that it does indeed equal 2. So underneath our square root, we have 7 times 2 is 14 plus 50. 14 plus 50 gives us 64. And if we take the principal square root of 64, we get 8. And 8 minus 6 does equal 2. That is true. So x equals 2 is a valid solution to this radical equation. We also need to check our other possible solution, x equals +7. So if we plug that into our original equation, replacing the x with -7, here's how that would look. Let me box this off just so that it's clear that that's separate from what we're now checking with this -7 for x. So underneath our square root, we have -7 times +7, which gives us -49. So the square root of, underneath this radical, -49 plus 50 minus 6 equals -7. Inside of that square root, -49 plus 50 is 1. And the principal square root of 1 is also just 1 because, of course, +1 times itself does equal 1. So we have 1 minus 6 is equal to -7, but that is not true because that would say that -5 is equal to -7. And since that is false, the solution x equals -7 doesn't actually work. We say that that is an extraneous solution, meaning it seems like it was true at first, but it didn't work when we plugged it back into that original equation. All right, let's try another example. So we'll start off with a radical equation, which we can begin solving by getting the radical by itself. So we need to move this -x to the other side of our equation by adding it to both sides. And now we have x minus 2. Notice that I'm not putting x and -2 together into one term because they are not like terms. And we've got x minus 2 equal to the square root of 3x minus 6. Now when we square both sides of the equal sign here, we have to remember that x minus 2 all squared is not the same as just doing x squared minus 2 squared. The correct way to multiply x minus 2 times itself is to distribute that out as a polynomial. So that would give us x times x is x squared. Negative 2 times x is negative 2x. Same thing for this, negative 2 times x. And negative 2 times negative 2 gives us positive 4. We have some like terms in the middle here that we can combine. So this is x squared minus 4x plus 4. So let's rewrite that up here. And on the other side of our equal sign, the square root that is raised to the power of 2 cancels out because those are inverse operations. And to finish solving this, we want to put this into standard form so that we can factor it. So let's move both of these terms to the other side of our equation so that we'll have all of our terms together on this side and the other side of our equation will just equal 0. And I'm moving these terms over to the side that has x squared with a positive 1 as its coefficient because that's going to make our factoring go a little bit smoother. So we've got x squared and then the like terms from negative 4x and negative 3x gives us negative 7x. 4 plus 6 gives us plus 10. And we have all of that equal to 0. If we factor this, then we want to find the solutions to this puzzle. What two numbers will multiply to equal positive 10 and add to equal negative 7? And we can use negative 2 and negative 5 to break that apart. So this becomes x minus 2 times x minus 5 is equal to 0. And we have two possible solutions from that. If we solve this factor, x minus 2, set it equal to 0, then x would equal positive 2. And if we solve this factor by setting it equal to 0 and solving for x, x would equal positive 5. But since the equation that we were solving originally was not just a quadratic equation, but a radical equation, we need to check our answers by making sure that they satisfy the original radical equation. And we'll check that on this next page here, so we've got plenty of space to work. So we need to check both of these possible answers by plugging them back into the original equation for x. First, let's check if x equals positive 2 is a valid solution. So we're going to keep this equation the same, but replace anywhere that we see x in that equation with positive 2. Underneath our square root, we've got 3 times 2, which is 6, minus 6, which is 0. So we have really the square root of 0. And well, what is the square root of 0? That is the number that if we multiply it times itself equals 0. And that is also just equal to 0 because, of course, 0 times itself is still 0. And it looks like this answer does work out because we get negative 2 equals negative 2, and that is true. So x equals 2 is a valid solution. Let's also check the second possibility, x equals 5, by plugging that into our original equation. And remember that the solutions that don't work when we plug them into the original equation, if we got something that was not true, like if we had something like 5 equals 8 instead of -2 equals -2, that would be called an extraneous solution. So in this case, we have So to check this other possibility, I've rewritten our original equation, but now plugging in +5 where we had x. So let's simplify the inside of this radical first. We've got 3 times 5 is 15, and 15 minus 6 gives us 9. The principal square root of 9 is +3. So this equation says -2 equals 3 minus 5. And that is also true because 3 minus 5 is -2. So this is also a valid solution. X is equal to 5.